How do you verify a trig identity algebraically? There are 3 steps that you can use to verify the trig identity. The first step is to choose the side that you want to work with. You can work with the left-hand side of the equal sign or the right-hand side of the equal sign. And the second step is to add, factor, simplify using the fundamental identities. Step 3 is to get the side you worked with equal to the other side of the equation. So in this example, we have cosecant squared of theta minus cosine squared of theta times cosecant squared of theta equals 1. And for step 1, I chose the left-hand side to work with. And in step 2, I just rewrote the left-hand side and I put it equal to the right-hand side, which is 1. And then according to the rule of factoring, you can factor out cosecant squared of theta, and we get cosecant squared of theta times 1 minus cosine of theta equals right-hand side. And then this whole thing would turn into sine squared theta because of the Pythagorean identities, because cosine squared theta plus sine squared theta equals 1. So then we can take cosecant squared of theta and we can turn that into 1 over sine squared of theta because of the reciprocal identities, and I just brought this down. So if you cancel them out, because this is in the denominator and that's in the numerator, you're just left with 1. So you have 1 equals right-hand side of theta, right-hand side, sorry. So that means 1 equals 1. And then over here, since 1 equals 1, cosecant squared of theta minus cosine squared of theta times cosecant squared of theta equals 1, or in other words, this whole equation is true. Here's another example that we can use. This one is cotangent of theta all over 1 plus cotangent squared of theta equals sine theta times cosine of theta. So I chose to work on the left-hand side, and over here I just set the left-hand side equal to the right-hand side, which is sine of theta times cosine of theta. So first I looked at the denominator on the left-hand side, and I saw that this one, you can just turn that into cosecant squared of theta according to the identities. And then this whole thing, cotangent, would be turned into cosine of theta over sine of theta. And then I brought over the cosecant of theta over here. So this is basically the same thing as that, but expanded. And then if you follow the arrow, we're on this side now. So you can cross out the sine of theta, and over here it's sine squared of theta. So since there's 2, you can cross out one of them. So basically we're just left with sine of theta over here. So then you have cosine of theta times sine of theta equals right-hand side. And then that means that cosine of theta times sine of theta equals cosine of theta times sine of theta, which is the right-hand side. And that's basically what I summarized down here. So that means, since this is true, that means cotangent of theta over 1 plus cotangent squared of theta equals sine of theta times cosine of theta. So this equation would be true. Now we have to verify the trig identity graphically. This one is also really simple. The first step would be to enter both sides of the equal sign into a graphing calculator. Then you make sure that the graphs are aligned. If they're not aligned, then the equation is not true. For my first example, I chose sine squared of theta plus cosine squared of theta equals 1. So in the calculator, you would plug in y1 equals sine of x squared plus cosine of x squared. And then for y2, so this would be like 2 different equations. So y2 would equal 1. So then for step 2, you just compare the graphs. Another way you could look at it is just see if the graphs look like one graph. Because if they're aligned, then that means that they're just like the same graph to put together. So I used an online calculator to print this out. And I put in the first equation and the second equation. And then so you would get that sine of x squared plus cosine of x squared is where y equals 1. So that sine of x squared plus cosine of x squared does equal 1. And all you see is one equation right here. One graph, sorry. In the second example that I chose secant of x times sine of x equals tan of x. So I plugged in y1 equals secant of x times sine of x. For y2, I plugged in tan of x. And then I just compared the graphs to make sure that they're aligned. So here's what the graph looks, and it might be a little hard to see or not, but they are aligned. It just looks like one graph, so that means that the equation that was there before is true. I hope this video was helpful. Thank you.